This is exercise 6G on solving cubic inequalities on page 242 of your textbook. This is really just an extension of what you guys already know. We're combining our understanding of quadratic inequalities and cubic graphing. So over here, I've got find, where x is x cubed plus x squared minus 5x plus 3 is less than or equal to 0. What I'm actually going to do is I'm going to treat it as if it is just an equal sign for now. So from there, I just have to graph it. So what's the first step I have to do towards graphing this polynomial? Sorry? Yeah, it is y equals 0, but before I can do that, I have to factorize it. Because I can't just look at this and be like, okay, let's just find our y-intercept, or our x-intercept, sorry. So I'm going to factorize it. What do I have to do to factorize? What theorem starts with R? Nice, remainder theorem. So I'm going to look for numbers that are factors of positive 3. What are the factors of positive 3? 1, -1. Good. And positive negative 3. Lovely. I'm going to start with the easiest one. Let's just do 1. So I'm going to put P of 1, which gives me 1 cubed plus 1 squared minus 5 times 1 plus 3. That should not be a circle. Alright, are we okay with that? I haven't gone too quickly, have I? No? Okay. From there, I just simplify that. I get 1 cubed plus 1 squared is just 2, minus 5 plus 3, which I know off the bat gives me 0. Perfect. What a coincidence. We got this one. So if I've got P of 1 gives me 0. Therefore, whatever factor that is whatever that is a factor. So I said that x equals to 1, didn't I? So what I'm going to do is I'm going to rearrange it so I get everything on one side and 0 on the other. In other words, I'm going to take away 1 from both sides. X minus 1 equals to 0. Are we okay with that? Lovely. So x minus 1 is our factor. I'm going to use long division in order to find what my other factors are. I've got x cubed. I'm going to rewrite this in a different color actually. I've got x cubed plus x squared minus 5x plus 3. I'm going to go through this a little bit quickly. Hopefully you guys are generally quite familiar with long polynomial division. I have to multiply x by x squared in order to get x cubed, so x squared goes over there. I get x cubed as a result. Negative 1 times by x squared gives us negative x squared. I'm going to put my implied negative brackets over there. X cubed take away x gives me 0. X squared minus negative x squared gives me 2x. Please don't make that mistake. A lot of people make the mistake of doing that and accidentally cancelling out when there shouldn't be cancelled out. I'm going to bring down the negative 5x, so I get 2x squared minus 5x. I think to myself, what value do I have to multiply x by to get 2x squared? And the answer is positive 2x. So I get 2x squared over here. Multiply 2x by negative 1 to get negative 2x. Implied subtraction. And I get 0 for the first term, obviously. And obviously I get negative 5x take away negative 2x. So negative 5 plus 2 gives us negative 3x. I bring down the plus 3. I think to myself, what number do I have to multiply x by to get negative 3x? The answer is negative 3. So I get negative 3x and then multiply the negative 1 and the negative 3, which gives us positive 3. Off the bat, I know that gives me 0 as a remainder. We've done it right. So I know that this equation right here is the same as x minus 1 multiplied by x squared plus 2x minus 3. Is it possible for me to find my x-intercepts now? What do I have to do beforehand? I have to factorize. I have to factorize that quadratic equation. I'm going to keep that x minus 1 out of that picture for now. I'm going to focus on that quadratic. So what method can I use to find the intercepts? Cross method, awesome. I'm going to think about what are the factors of x squared. I know the factors of x squared is just x and x, obviously besides 1 and x squared in themselves. And I'm thinking what numbers multiply to give me negative 3? 1 and 3, or plus or minus 1 and 3. So in this case, one of them has to be negative because it's going to end up as a negative when I multiply them. And it also needs to add to positive 2. So off the bat, I know that it's plus 3 minus 1. Okay? Because if I multiply x and negative 1, I get negative x. Multiply x and positive 3, I get positive 3x, which adds to give me positive 2x. I draw my line in the middle over here, and I go x plus 3, x minus 1. However, I can't ignore this one over here. I bring that over here, and I get x minus 1. Are we okay with that factorization there? Lovely. We've got a repeated factor, don't we? I'm going to write equals x plus 3, x minus 1 squared. It's a repeated factor. And hopefully you remember from me saying this last lesson, talking about how repeated factors look in a graphical sense. I'm going to quickly graph this because off the bat I can tell that my x-intercepts are. My x-intercepts are y equals 0. I get x equals to negative 3 and positive 1. Thank you very much. I'm going to graph that very roughly on the right hand side over here. So I get negative 3. Let's put that there. And positive 1. Let's go and find my y-intercept. So my y-intercept, I let x equal to 0. I guess, and I'm going to use this equation right here. So I get y equals to 3 bracket and then negative 1 squared. 3 times negative 1 squared gives me just 3. Am I going too quickly? Have I lost anyone? Okay. From there, I get that. Let's put that over there. That's my y-intercept there. What shape is my graph? Is it positive or negative? Is there, when I have it fully expanded, or in this case, the original form, is there a negative in front of the x cubed? No, so it's a positive. And hopefully you guys remember my rough table, where positive linear goes up, positive quadratic goes down, and then positive cubic goes back up. So it goes up, and I know my graph looks something like this. Something like that. And I can test it. Let's say I put x is 2. So let's find p of 2. And I get, I'm going to go ahead and use this equation again. It's a bit easier. I get 2 plus 3, which is 5. Oops, sorry. 5. And then I get 5 times x minus 1, which is 2 minus 1, which is 1, squared equals to 5. So what's gone wrong here? When I sub in p equals 2, so that's along this dotted line here, it should be a positive 5, shouldn't it? In my graph, is that a positive 5? No, so I have to fix my graph. And also, we forgot to include the idea of the repeated factor. So can anyone tell me, what does the repeated factor mean in a graphical sense? Yes, thank you for motioning it. Basically, it just means it's symmetrical on both sides. It's a turning point. So what it looks like is something like this. Oh, let's try that again. I think we can do better. There we go. You can see how at x equals to positive 1, we have a repeated factor, and therefore it's going to be what we consider a quadratic there. Okay? Any questions about that so far? No? Okay, so let's go back to the original question. It wasn't graph it or solve it. It said find when that equation is less than or equal to 0. When is this graph? Let's start with, when is that graph equal to 0? When x is negative 3 and negative 1. When is this graph less than 0? When does it have a negative y value? Less than negative 3. So I can write as x is equal to, or rather my domain, is equal to negative infinity, and hopefully you guys remember this notation, to negative 3, including negative 3, in union with 1. In other words, all that's saying is that from all the way towards the left, negative infinity, up until negative 3, including negative 3, and also including 1, that's when this graph has a y value of either 0 or some negative value. Now my question is, in terms of function notation, in terms of that answer right there, how do I know it includes negative 3? Thank you. The square bracket means we're including that point there. And obviously for infinity, we can't include infinity. It doesn't exist in reality, so we just use a circle bracket. Do I have any questions about this? No? So just to quickly review, we treat it as if it's an equal sign, we sketch, we graph, we solve, blah, 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 and then using that graph, we find when that graph is positive or negative, depending on what the question's asking. So it's the same as quadratic inequalities from there. All right, awesome. So that's exercise 6G.